Jared Rosenberg, you hold a PhD in exercise science from Syracuse University, have years of experience working as an exercise physiologist and teaching, dozens of publications in prestigious journals for cancer and metabolic disease research. Some might consider you an academic weapon and a former powerlifter as well. Welcome.
Thanks. I really appreciate the warm welcome. Always a pleasure talking to you, Jeremy.
Yeah, it's been a long time. So, for those of you who don't know, me and Jared go way back a couple years ago. What is it, maybe 4 or 5 years now from
It
Dr.
might be
King's lab?
more. It might be. Yeah, I wasn't even married. Probably closer to six. Yeah.
Yeah, yeah. So, this was back when I was an undergrad, exercise science major. Jared was one of my TAs as well as a co-author on a couple of publications on exercise physiology. And just the other day, I thought to myself, you know what? Jared would be a great addition to this podcast that I'm starting. So love to have you here, man. So let's get right into it. What do you do these days? What are you into? What's your expertise in?
Yeah, thanks. I appreciate like I said, appreciate you having me on. My expertise is a little bit widespread, but how I kind of explain it is I am particularly interested in asking the question, can we predict the future? In specifically context of lifestyle and fitness interventions, specifically related to metabolic health and overall well-being. So to kind of put a little bit more simply, I'm particularly interested in can we look at a biomarker at baseline before you go through some type of dietary or fitness intervention? And can that biomarker tell us about what will happen after we have these individuals go through this specific lifestyle intervention?
Mhm. Before we get into the nitty-gritty details, the biomarkers and the prediction, the actual research that you're doing, can you just give us a quick overview? What are metabolic diseases and why are they so prevalent, especially now in Western civilization?
Yeah, again, just a great question. So thank you for kind of spelling that out. Because I think when we talk about metabolic syndromes, metabolic disease, I think a lot of people kind of use those as a catch-all without really understanding one, what is metabolism? And metabolism is the sum product of all chemical reactions in the body. And within metabolism, there are two different types. There's catabolism, which is the breakdown, and there's anabolism, which is the build-up. So you might oftentimes hear people say, "Oh, my metabolism changed, and that has resulted in me X, Y, and Z, losing weight, gaining weight, whatever it is." But that's not really how it works because metabolism is, you can think of it as a formula. There's an addition, which is anabolism, and a breakdown, which is catabolism. So that is what metabolism is. And in relationship to the buildup and breaking down, we're really specifically talking about nutrients. So you can think about this as you eat food, it gets broken down. It gets broken down into its individual components, the nutrients, and then it gets built up into the body into specific tissues. When it comes to what metabolic disease is, or metabolic syndrome, or any type of dysregulation within metabolism, it is any part of that formula, whether it be the breakdown or the buildup, that gets disrupted in any shape, form, or fashion, and that leads to an overproduction or underproduction of essential nutrients within the body, which is the long-winded answer of basically saying it encompasses a lot, but it is very specific. As to the second part of your question, uh, that's much easier to answer. The reason why metabolic syndrome, high rates of metabolic diseases are so prevalent, specifically in the Western world, are because we don't have to work very hard for the food that we eat, meaning we don't have to move a lot, we don't have to spend a lot of energy. And oftentimes, that food that we eat is often consumed in large quantities and is oftentimes not very good for us.
Precisely, precisely. So I am not a big fan of the whole if it fits your macros diet. I'm sure you can agree because food is so much more than just the calories, than just the amount of protein. If you want to keep it super simple, maybe just looking at your protein and calories for body composition, body weight, absolutely that can be a useful metric. If you had to pick two, those probably would be the ones that make the most sense. But in reality, the food that we're eating, they're affecting our hormones, and hormones are these signaling molecules that tell our body what to do with the food that we're doing. So in essence, I've heard many experts in the longevity, the metabolic health, the fitness, bodybuilding field refer to metabolic health as essentially how good are you? How good is your body system, all encompassed, at generating usable energy? Mitochondria, ATP, instead of having these interference things such as the case of diabetes or high cholesterol levels, you need the glucose, you need the cholesterol, but your body is clearly not using them properly, and that's causing a lot of disrupt. There's a lot of positive feedback. It's almost like a vicious cycle. Would you agree with that statement that the overarching, maybe it's practically you can't really measure this, perhaps with VO2 max you can kind of predict and stuff, but your metabolic health, your age, your biological age, in essence, is pretty much how well you can generate usable energy with the nutrients that you take in, or would you disagree with that?
Yeah, I'm going to answer that kind of nuancedly. I would say in an overview, I do largely agree. But where I think the nuance is important, and it's not just me kind of picking on any one particular thing, but I think those one particular things are why we're specifically in the research field, right? And I agree kind of with the overview. And the way that I think about the way that you just described is it's energy mismatch, right? Where if you're pushing a cart and you have X amount of units, you want the X amount of units to equal X amount of units that that cart has moved, right? And if there's any type of metabolic dysregulation, that's a mismatch. And that's, I think, exactly what you were talking about. Where I think the nuance is important is I think that there are certain contexts, certain conditions where maybe it's a little bit different for different reasons, and that makes it really specifically hard to particularly measure, where it makes it where maybe that what we just kind of talked about is fits most people and fits most metabolic diseases, fits most conditions. But in terms of it being a catch-all, I think at its sum, it does a good job. But I think that there are some people on either end of that spectrum where maybe it doesn't fully encapsulate that, where I think that there are other things that are candidly outside of my scope of practice that are more systemic, such as areas in which that you live, environmental factors, many other factors that we do know that plays a role in these metabolic conditions that were just aforementioned. That makes it a little bit harder to say 100% yes, Jeremy, I agree with you, as opposed to I think I mostly agree with you.
I see, I see. So we're pretty much mostly on the same page, but when it gets down into the fine details, the details do matter, of course. So some common and perhaps uncommon signs and symptoms of poor metabolic health. I have a little running list going here, but if you have any to add on, just let me know. But we have things like elevated fasting blood glucose, hypertension chronically, poor energy levels, always feeling fatigued, poor body composition, having an excess of body fat, especially visceral body fat, which we know has a lot of negative health outcomes long term, hormonal imbalances, insulin being too high, cortisol being too high or crashed, testosterone, estrogen, IGF-1. These are all related to, of course, the metabolic syndrome, the cluster of correlated different issues that tend to come together. Have I missed any of the common signs and symptoms of metabolic disease?
Yeah, I'd speculate this or specify this, but I'm not a medical professional, so I just want a medical professional. I just want to make sure that's clear. I would largely agree with most of what you said. You mentioned body composition. One thing that I'm trying to parse out with my own kind of research is what is kind of more important? Is it total muscle mass or is it muscle mass relative to fat mass? So that's one where when you mentioned body composition, I think that maybe we should also address that from maybe two potential different ways. And the reason why I bring that up is because for some individuals who have a high BMI, they have a high body mass, they have a high amount of muscle mass, but that doesn't necessarily mean that they're healthy. I would actually argue the opposite, that they're not healthy. And then on the other end of the spectrum, we have people with very low BMIs, but still have low muscle mass. And obviously, both those people that I described would also have high body fat percentage because they have a low amount of muscle mass. But where I think there's another layer that maybe needs to be added to this is the question is for particularly those individuals with high BMI, where they do have a higher muscle mass and a higher body fat is what would be the best way to go about their treatment? Would it be a reduction in body fat or an increase in muscle mass? And I think that's why that's important to assess body composition from both those, not only a relative, but an absolute perspective.
Mhm. Which one is the lowest hanging fruit that's going to drive the needle furthest when it comes to positive health outcomes? That is the question that we all care about. The so what? What can we do about this very, very prevalent issue that is kind of taking America by storm? And time again, longevity experts such as Thomas DeLauer, Dr. Gabriel Leone, Paul Saladino, bunch of other guys and girls, they will all pretty much agree that muscle, skeletal muscle mass specifically, is the organ of longevity. It's not just about how much you can lift, but it's genuinely a organ that has endocrine function. There's hormonal,
Yes.
cytokine. Generally speaking,
And paracrine
muscles
function too, yes.
yeah. Muscles are anti-inflammatory. Adipose tissue, especially in excess, especially visceral adiposity. So in the gut area, classic pre-diabetic, classic type 2 diabetic kind of phenotype, where someone has that beer gut, or even bodybuilders who are really, really shredded, there's a lot of speculation that perhaps they're kind of running into the metabolic syndrome, the visceral adiposity. They have a six pack, so they're lean on paper, maybe, but what does it actually look like on the inside from a health perspective? Perhaps not the best. So yeah, absolutely. The question is not just BMI. At this point, I think we can all agree BMI as a standalone metric on someone's health is kind of garbage. We really care about what the body composition is. That's where body fat, bioelectrical impedance, DEXA, hydrostatic weighing, FFMI, all these other different tools to assess body composition is what matters. It's not how much you weigh, it's really about what you're made of. And that's going to give us more insight into your overall metabolic health. So, with that said, Jared, how do you, as a researcher in this kind of field, what kind of biomarkers or things, variables are you looking at to assess someone's metabolic health?
Yeah, again, you just keep on going with the good questions, Jeremy, today. So we in my research, we collect everything, right? We don't everything that we can, I should specify. So it's not that I take special preference on one versus the other. What we do is we take everything. Where my research, though, has been specifically looking at is kind of what was just aforementioned, was specifically looking at muscle mass at baseline, muscle mass that has accrued through the specific dietary and fitness program, as well as body composition in terms of total fat mass, in terms of body fat percentage, and we've also trying to figure out different ways to quantify visceral adipose tissue. Some equipment that we have does quantify that, and some doesn't specifically quantify that. And looking at that as its kind of own individual marker, as opposed to just general adiposity as well.
Mhm. If money wasn't an issue, if you had unlimited funding, which of course is kind of hard to do right now
Yeah.
with the current state of the government, but let's just say hypothetically you had unlimited funding and you genuinely wanted to assess someone's metabolic health. You're looking at the biomarkers that you're familiar with. What devices or biomarkers specifically, could you give us a little running list on what you'd be looking into?
Absolutely. The very first thing, if I had unlimited money, is everyone would do some type of MRI or hydrostatic weigh-in, which are the gold standards of assessing body composition. Within MRI as well, we would also be able to look at within each individual body part as well, because we were sort of kind of alluding to this, as you mentioned, VAT. VAT is visceral adipose tissue. It is stored not kind of ubiquitously in the body, but in certain spots. So I would make sure that I did the MRI and a hydrostatic weighing because that way I could get the gold standard of assessing body composition, specifically body fat percentage, but that was also understanding where adipose tissue and muscle mass is laid down as well. Then, in terms of blood biomarkers, I would want to look at fasting blood glucose, and then I would also want to look at postprandial blood glucose as well as fasting insulin and postprandial insulin levels. Postprandial means after a meal. So the gold standard right now of doing that is this thing called an oral glucose tolerance test, where you take basically 75 grams of sugar, you drink it, and then we assess your blood biomarkers, specifically blood glucose and insulin levels over the course of that time. Typically, we're going to collect that at 30, 60, and 90 minutes over the course of 2 hours. And within that, what that will be able to do is that will be able to tell us two key things. One is about insulin sensitivity, and the other is about beta cell function. Now, you mentioned a few times like fasting blood glucose. And I know that you and I have talked about this offline a bunch of times, but fasting blood glucose is a fine marker to take. But the problem with, I don't want to say the problem, but the limitation is a better word. The limitation of fasting blood glucose is that it doesn't always tell us specifically about an individual's insulin resistance. And that is the key driver of type 2 diabetes. And other people have speculated resistance is the key driver behind a whole host of other metabolic dysregulations. So simply just looking at fasting blood glucose doesn't unfortunately tell you too much about the specificity of someone's insulin resistance. You really need to see how they handle that elevated blood glucose to see how that is brought down in relationship to how
Ah,
much insulin it takes for them to get that as well.
I see. That is very similar to when we're looking at an athlete's squat form and something's going wrong. We're probably not going to pick anything up, especially if they're a high level athlete, if they're only squatting 45 pounds. You have to see what it looks like when something gives out, when the knees go into the valgus position, the hips don't rotate properly. And that only really surfaces when you've reached the threshold of that athlete's capacity
Under stress.
tolerate, right? So it's exactly your metabolic health is essentially how good are you at handling day-to-day stresses, including spikes and valleys of blood glucose. Now, to just clarify here on your point there with the fasting blood glucose, by and large, it's a very practical, cheap, easily
Yes.
accessible measure. But with that said, you know how with diagnostic tests, they tend to have very good specificity but not great sensitivity. But with screening tests, such as a COVID, we have very good sensitivity,
Yeah.
poor specificity. And for the audience, just to make sure that they understand, when we're talking about sensitivity and specificity, spin and snout. Snout sensitivity, if it's highly sensitive, it's very good at ruling things out. But the caveat there is there's a high chance of false positives.
Yeah,
On the other
over.
hand, with diagnostic tests, we have specificity, spin, ruling in, SPIN. That's great for actually diagnosing the issue, but there's always the chance of false negatives.
Yeah.
With that said, I know Tiago, professor, would be super proud of me understanding that. But with that
I'm
said,
proud of you too.
thanks, Jared. Jared was actually my TA many years ago. However, but with that said, is fasting blood glucose, especially not just one metric, but the trends, would you say that is more on the side of the highly specific and diagnostic in terms of measuring your insulin sensitivity and metabolic health? Or is it more on the screening side of things where there's a pretty good chance that even if it's in out of range, it doesn't necessarily mean that something's wrong or vice versa.
Yeah. The one thing that I'll say is that it's a good question. The research on that, how that sort of kind of looked to address that is from longitudinal studies, where they've looked at people's fasting blood glucose and then had them come back 2, 3, 5 years later, and then seen if they have any of those metabolic disturbances. Mostly, this is specifically in context of type 2 diabetes, as type 2 diabetes is hyperglycemia, high blood sugar. So. So it's hard to say, is it more about like the diagnostic or which one it specifically is in that from a longitudinal standpoint. From a cross-sectional standpoint, I think if we were to break that up, I do think that it includes more people than you see issues with. So I would say it probably has a high degree of false positives in that regard. And I think the reason for that is mostly methodological, where your blood glucose is very variable. And when research has looked at the reliability of people's blood glucose, there is a decent amount of variability from day to day, which I think is not to discredit anything that, we just talked about. I think it is just to actually, I think it really signifies the importance of looking at one, those postprandial measures. And two, assessing blood glucose is not only a biomarker of one period, but as a trend in general.
Oh, okay. Okay.
Yeah,
So
depending.
again, it's all about the end, the population, the sample size. The more data you collect, the better stuff you can actually assess from that and observe. The trends is what we're looking at, if anything, not just one marker being off, especially when it comes to a very sensitive test that is prone to false positives, such as the fasting blood glucose measurements alone.
Exactly for fall, especially for blood glucose. Yes, I would argue for other measures that we briefly talked about, such as body composition,
Mhm.
muscle mass. Those things do not change that much as long as you have a good measure that's taken it.
I
So I would
see.
argue that it really is dependent on the marker that you're taking. Exactly.
Okay, okay. So to summarize, fasting blood glucose, it's okay. And for the price that you have to pay, the accessibility, it's really good. But that alone is absolutely not diagnostic for any sort of metabolic disease necessarily. Now,
Yeah, I would say it's kind of prognostic, right? Where if it's growing up, it's gonna be it's means you have hype. If you have above 126 milligrams per deciliter, you are type 2 diabetic, right? So
mhm.
I don't want to say that it's not diagnostic per se in that sense. I just think that looking at it one time in isolation, especially without the context of looking at insulin or maybe some of the lipoproteins that you mentioned with cholesterol, I
Mhm.
think is I don't want to say incomplete, but I think there needs to be more done to that or more workups other than that.
Yeah, yeah. I mean, generally, a medical doctor that is traditionally trained, if they see a high fasting blood glucose, their next course of action is likely to look at a hemoglobin A1C,
Exactly.
which would be way more indicative or diagnostic probability, right?
And
Now,
to that point, hemoglobin A1C is a measure of hemoglobin over the glucose on the hemoglobin over the course of 90 days. So that is kind of that longer set thing. So it's exactly what we were just mentioning. Yes.
yeah, yeah. And that 90 days is because the average life cycle of a red blood cell is about
90
90,
days.
right?
Yep.
Awesome.
Exactly.
Going back to measurements here, we have fasting blood glucose, we have the oral glucose tolerance test, abbreviated to OGTT, we
Yep.
have the homeostatic model of insulin resistance, the HOMA-IR,
Mhm.
and then I believe, in my understanding, if I'm not mistaken, the gold standard to assessing systemic insulin resistance is was it a euglycemic, hyperinsulinic, something, something clamp?
The hyperglycemic euglycemic clamp. So it's a
Okay, I almost got it right. Can you talk to us about the difference between those, specifically that gold standard one?
Yeah, so they're two completely different tests. An oral glucose tolerance test it's kind of what I described again, but just for the sake of this conversation, it is basically you take 75 grams of a glucose drink and you sit there and you have your blood measured. Most doctors will only measure it pre-post. A lot of research has talked about why you want to measure at 30, 60, 90, and 120 because you can get a lot of different biomarkers that are a little bit more predictive than just the traditional ones recommended by the ADA, which is 0 and 20.
Uh-huh.
When it comes to HOMA-IR, homeostatic assessment of insulin resistance, is a fasting marker. So you don't need to do an oral glucose tolerance test to get someone's HOMA-IR. You just need blood glucose and fasting insulin, both at the fasting levels. When this comes to the hyperglycemic clamp, it's so what that is looking at is that is literally measuring. So when we talk about insulin sensitivity or insulin resistance, which is the inverse of sensitivity, what we are assuming if we're taking a fasting measure or even in an oral glucose tolerance test is that if your blood glucose was raised through that drink and it has no longer in your blood. So we've taken it from 60 to 90 minutes, let's say, right? And let's just use arbitrary numbers. Let's say it was 200 at 60 and 150 at 90. We assume that that has where did it go, right? Well, we're assuming that it has gone into the muscle, which is a safe assumption because that is what, or fat tissue, but that is what insulin is doing. It is driving those nutrients into the cell. That's what insulin does. When that comes to the clamp, however, what we are actually able to measure, and so what we're able to measure is if we know what the insulin levels are consistently, and then we're measuring those blood glucose, we can basically measure this thing called M. And this is a measure that is directly measuring the uptake of glucose into the cells, obviously via insulin, which we are controlling, or not we, but the medical professionals are controlling. So that way we can directly measure glucose uptake, and glucose uptake essentially is what insulin sensitivity is.
Does that involve a radioisotope of the glucose to see exactly where in the body that gets partitioned into?
Yeah, we can do radioisotopes with that. I've never done studies that have used radioisotopic data. There have been some of that has done that, I know, on fat cells to look at specifically triglycerides or other fat molecules, how those have been either raised or deposited within the cells. But that is a good question. It's a little bit outside of kind of where I kind of sit in my expertise.
I see, I see. So going back to the gold standard, what exactly is the clamp talking about? What are we clamping?
Thank you. So I probably should have specified, right? So we're clamping insulin levels at, or holding them steady. So it's not a true clamp in the terms of like what you might think about it, but we're holding insulin levels steady. So that way, of course, we know how much insulin is taken to deposit the glucose into the cells. Because if we're not quote unquote clamping that, if it's a more live environment, such as like an oral glucose tolerance test, we're not controlling the release of insulin. But if we are in the clamp or actually injecting insulin and controlling that, we know that insulin levels are staying steady. So therefore, then we can assess the relationships of glucose to that steady insulin levels that we are quote unquote clamping.
I see. So practically, or really what's going on here is if someone has very good metabolic health and very good insulin sensitivity, by extension, what that really means is they don't need as much insulin to get rid of a large amount of glucose. Is there a golden ratio that you're looking for? I believe in the medical field for type 1 diabetics, it's around 15 grams of glucose per unit of insulin. But is there a threshold, if you will?
Yeah, I'm not sure exactly in type 2 diabetics, because obviously with type 1 diabetics, the issue there is the actual insulin. They lack the beta cells to secrete the insulin. So I'm not exactly sure if there are specific threshold cutoff points
Mhm.
within looking of the insulin to glucose ratio. So that because obviously as adiposity grows, as insulin resistance grows, it's going to take more insulin to get the glucose into the cells.
Mhm.
And obviously in the hyperglycemic test, if insulin is set at what it's set at, then we know then you're gonna have glucose in the blood for longer periods of time and less will be disposed of. So that disposal rates will be lowered.
Okay. Well, speaking of thresholds, going back to your point there about body fat, body composition, muscle mass, the research there, is there any thresholds for muscle mass or body fat as a percent of body weight or something like that, that would say if someone is age 60 and they're above this amount of muscle mass, or if they're below this amount of visceral adiposity or body fat percent, they would unlikely develop a metabolic related disease in the future. Is there a threshold for that prognostic value?
Yeah, not that I'm aware of. I think that that would be a nice place for the research to go. I think tying this back to BMI, while BMI, I think agree is not good on an individual level, on a population level, it is appropriate, right? Because it's a general trend, but more importantly, what BMI gives us is it gives us cutoff values, right? Above 30 is obese, above 25 is overweight. So I think that would be a really good place for a lot of the research to kind of go is to try and look at the qualifications of specific cutoff markers where we can kind of be objective because I like where that question was going because right now in kind of general terms, I will say to people, you should have more muscle mass, you should have less fat.
Mhm.
And I will stand by those statements as general statements, but I don't necessarily know if they're super helpful because I'm not sure how prescriptive they should be, as opposed to with BMI, we should lower your BMI 2 units, right? And
Yeah.
that's quantifiable, that's
Mhm.
measurable, and that's and I wouldn't say it's easy to attain, but it's easy to understand in a conceptual standpoint, as opposed to saying to someone like, yeah, we should lower your body fat. Well, again, generality, that's probably a correct statement, especially if they're an individual with high adiposity.
Mhm.
what does that necessarily look like? How do we go about the pragmatism of that? So I think that's a really good question. I'm not familiar with research that has specific cutoff markers for that. But I think part of the reason why, and we can kind of get into this when it comes to measuring things other than BMI, is when we're talking about measuring adiposity or measuring muscle mass, we have a lot of different measures, and a lot of them aren't as accurate or reliable, or in that case, with both, as we kind of would like them to be, which makes it even more kind of muddy to even be prescriptive based off of measures that we're not even sure are accurate measures.
Yeah, yeah. So, in summary, if we're talking about theoretically, we have enough research to pretty confidently say, generally speaking, if you increase your muscle mass and you decrease your body fat, that's better than not doing that for your health. But when it comes to in practice and giving people prescriptions and dosages and thresholds to aim for those specific metrics, whether it's FFMI, visceral adiposity, or BMI, or even body fat levels, that's where the water gets a little bit muddy. We don't exactly know where exactly those thresholds are. And that's the big challenge of research because it's so multifactorial. It's you're trying to make something that is kind of subjective, multivariable into a one unit objective measure. And that's probably a paradigm that's across all of research when it comes to health and fitness, right?
Yeah, well said, 100%.
Awesome. So, what are some pretty predictable health consequences of having chronic poor metabolic health?
Yeah, I mean, we've kind of led, kind of been hinting around this, but some of the more common ones are some of the things that are very common in our world today. Unfortunately, cardiovascular disease, obesity, type 2 diabetes, and of course, cardiovascular disease and type 2 diabetes are some of the leading comorbidities of health outcomes, unfortunately, for individuals. So really, anything like that, as well as there are some certain cancers that are definitely related with poor metabolic health as well. So really anything that is going back to the original question related to metabolic disease or dysregulation in any form or fashion, we do know that having poor metabolic health can cause an increased risk of having those diseases later on.
So just to name a few, we know diabetes, Alzheimer's, which some people argue is diabetes type 3,
Some people have said
cardiovascular
that, yes.
disease, and we got kidney disease, and then the advanced glycation end products, and of course the implications there. But I know that your research specifically, after I skimmed over your CV, is a lot on cancer, specifically breast cancer.
Yeah.
Yeah, can you enlighten us on what's the research there with metabolic health and cancer progression?
Yeah. So I study, body composition as that changes through breast cancer treatment. And what we've done is we've implemented lifestyle interventions in individuals going through breast cancer treatment. What we know is that breast cancer is very related to poor metabolic consequences. So we do see that having high blood glucose, hypertension, excess adiposity are independent risk factors for individuals with to develop breast cancer, unfortunately. So when it comes specifically to breast cancer, how a lot of breast cancer is treated, not all, but a good amount of it, will deteriorate body composition. As well as just cancer itself is a very fatigable event, which could cause you to exercise less, which would decrease muscle mass. Cancer cachexia is a big concern in the cancer world, and cancer cachexia, which is basically defined as just overall cachexia, which is muscle wasting, where we see a big breakdown of muscle tissue. And as we've talked about, one thing that I'm particularly interested in is muscle tissue. Individuals also may take glucocorticoids for to alleviate some of the symptoms of the treatment. They have prolonged glucocorticoids have also been shown because they're catabolic to break down muscle tissue as well.
Cortisol.
Cortisol, exactly.
Mhm.
Yep, you knew where I was going with that. Exactly.
Yeah.
So when it comes to what I'm specifically interested in is we were interested early on in can we just build a program for individuals that is in the form of a holistic program where we focus on resistance training and an increase in dietary protein consumption. Can that increase baseline muscle mass or at worst reverse some of the deterioration of muscle mass that we've seen? And we've found fantastic results in our 3-month trials where we've had individuals actually increase muscle mass while decrease in body fat, which oftentimes many people say you can't do both at the same time. But we have plenty of publications where we've shown that these individuals, even undergoing systemic radiation, chemotherapy, glucocorticoid treatment, decrease in overall energy, they're still able to have that increase in muscle mass and the decrease in body fat percentage, which we think is really important because we believe that that decrease in body composition uh, that some individuals may unfortunately encounter during cancer treatment, not just specifically breast cancer, could make them more susceptible for increased cancer rates in the future because of kind of what we talked about before, where if muscle tissue is this kind of reserve against these things, well, then that would make sense. Then if individuals go through treatment and it results in the decrease in muscle mass, and then we know that people who have cancer, unfortunately, are also more likely to also have another cancer later in the future. So we see that there could be a potential correlation there. Of course, correlation doesn't equal causation, but
Mhm.
when you see a large enough trend, we think that there could be something there. So in our trials, what we're specifically focused on again is making sure that those women have at least a net neutral in body mass and body in muscle mass from pre to post intervention is always the goal.
Yeah, and that totally makes a lot of sense. Speaking of correlations, because muscle mass is directly correlated to your VO2 max, and VO2 max is directly correlated to your mortality, morbidity, life expectancy.
You know what other marker we've talked about that muscle mass is directly inversely correlated with?
Is it insulin resistance?
It is HOMA IR. Exactly.
Yeah,
Exactly.
yeah, and we'll definitely touch on that here in just one second. Now, just going back to cancer, here is my general understanding on the progression of cancer in relation to metabolic disease. So, in essence, cancer is the abnormal, uncontrolled growth of a damaged cell that has not been taken out by the immune system. Well, if we're in a state of poor metabolic health, there's a dysregulation, imbalance in the anabolic catabolic signals that are all going on, including the hormones that are involved as well. You're causing a lot of inflammation systemically. And what comes with inflammation when those white blood cells are recruited? Well, one of the first things that happens is a surplus of oxidative stress. In the short term, that makes sense to get rid of pathogens, perhaps
Yep.
kill cancer here and there. But if it's happening perpetually, every single day after day, week after week, month after month, year after year, that inflammation, that oxidative stress starts to add up. And oxygen, the oxidative stress, starts to damage the DNA, the integrity of the entire cell for the whole body. It increases the risk that at least one of the trillions of cells that are in your body becomes cancerous, perhaps to the point where your immune system can't handle it. And of course, with metabolic disease, your immune system, if anything, high cortisol, low cortisol, it's going to suppress the immune system in the long term, would have a harder time detecting that. Plus, it's a higher risk. And of course, what does cancer love? It's that growth environment with cellular damage. And that's exactly the very thing that caused the cancer is also very often the thing that makes it worse in the long term if we don't fix it with a dietary or lifestyle intervention. Is that a pretty accurate summary on the cancer research in relation to metabolic disease, or have I left anything out there?
Yeah, so I don't study like the origins of cancer or when it comes to the cellular signaling or the even the epigenetic signaling from that. So I would say that I think based on my limited understanding of kind of the baseline of where cancer comes from and of it, I think that was elegantly said, but I'm not sure that I feel comfortable within my expertise kind of agreeing or disagreeing with really any specifics of that. But as a general overview, yeah, I think you nailed it.
Awesome, awesome. So, what is exactly at the forefront of metabolic research right now? Are there any new drugs that perhaps you'd want to enlighten us with?
Yeah, thanks again. You line up great questions. Hopefully I'm knocking down the bowling pins. One thing that, where we kind of met in the lab was studying incretin mimetics. And those are really probably what is the next, I would say the revolution's already here. These drugs seem to be at the forefront of definitely type 2 diabetes and weight loss, because that's what they're FDA approved for. But there seems to be other diseases that they seem to be very good at, which kind of makes sense with based on what we mentioned a few minutes ago with how metabolic dysregulation leads to a whole host of diseases. Well, it makes sense that if these drugs maybe potentially treat some underlying mechanisms of that, maybe they can be kind of this ubiquitous catch-all drug.
Yeah. So incretin mimetics, is that synonymous with GLP-1 agonists?
Yeah, thanks for clarifying that. So, when people say GLP-1 receptor agonist, what that is an incretin mimetic. And let's just take an overview and let's kind of work your way down. So, for my dissertation, what I was specifically focused on are two hormones, GLP-1, glucagonolate peptide 1, and GIP, gastric inhibitory polypeptide. Those are the two incretin hormones. Now, when you take an incretin mimetic, for the most part, unless you're taking a specific one, which we'll get to in a second. But something like Ozempic, well, that is semaglutide. That is a GLP-1 receptor agonist mimetic drug. And what that does is, even though you have that hormone that is secreted naturally in the presence of food, so postprandial, what it does is that hormone it's like, let's say we're talking about the natural endogenous hormone, right? So we go out to have a drink and, chicken wings after this or whatever. The fat and glucose in those meals will be sensed once they're, pass in the stomach and go through the intestines. It will secrete, you will have these cells that secrete GLP-1. Those will travel to the pancreas and they will cause an increase in insulin secretion, which then will bring glucose levels down. And think about once again what type 2 diabetes is. It's hyperglycemia.
Mhm.
So what these drugs do is they mimic that naturally secreted hormone, and they cause an increase in the secretion of insulin, which decreases blood glucose, which is how they treat type 2 diabetes.
Yeah. Now, when it comes to endogenous incretin secretion, in my understanding, working with you from what I can recall a few years ago, there is a difference in your measured insulin sensitivity of oral glucose versus injected glucose. Is that the incretin effect that we're talking about?
That is exactly what the imprinting effect is. So let's take kind of an overview of that, and then if you want, we can actually tie that to some of the incretin mimetic trials that have touched on that have actually been a little bit interesting in my opinion. So the incretin effect is this phenomenon where if you inject glucose into the cells compared to if you consume it, you would think that putting it into the that causing glucose directly into the veins would go hepatically and would cause this massive increase in insulin compared to if you consume it. However, what research has shown is it actually is higher when you consume it orally, even though it takes longer for the pancreas, the liver, and your body to sense that. And the reason for is because when you inject it intravenously, you are bypassing the gut, thus bypassing those cells that secrete GLP-1 and GIP, which cause that increase in insulin. So the incretin effect is the difference between the glucose excursion of insulin when it's consumed orally compared to intravenously. And it's a much higher amount when it's consumed orally compared to intravenously. Once again, those insulin concentrations.
Is there any sort of inverse or proportionate interaction or correlation between the effect size of that incretin effect and someone's metabolic health?
Absolutely. Yes. Another
All right,
great
talk
question.
to me about that. What's going on?
Yep. So what we know, and this was the origins of my dissertation, what we know is that incretin effect is attenuated as individuals increase in adiposity and independently increase in glycemic deterioration. So both an increase in adiposity and a progression towards type 2 diabetes cause that incretin effect to be lowered. But interestingly enough, where they cause it to be lowered is not from the intravenous side, but from the oral side, which shows that those incretin hormones are not causing that same secretion of insulin, thus driving the higher hyperglycemia seen as the phenotype in those individuals.
Okay. So that again is in line with metabolic health as a whole is largely going to be reflected by your glucose tolerance. And if we're talking about, again, how we define metabolism and metabolic health as perhaps a metric, a subjective metric, a theoretical metric on how well your body generates usable ATP, usable energy, well, the problem here is with poor metabolic health, you're not using the glucose, the substrates properly because there is dysregulated signaling. In this case, the incretin is not doing its job to make you feel satiated endogenously, right?
Potentially, where I was interested in is it that which would then argue the sensitivity, or is it the secretion? Because it could be both, right? Like you could not secrete as much, which would also reduce the amount of insulin release, or it could be secreted and it's not there, which would be
Uh-huh.
more analogous to the peripheral insulin resistance that we see in tissues. So
Yeah.
that was what my research was trying to hint at is, well, which one is it specifically? Kind of going back to my interest, if it was the former, if it was the amount of secretion, well, then this could be a biomarker that could be used to assess individuals' health.
Uh-huh. And that very much reminds me of the leptin hypothesis.
Yep.
Is it you're not secreting enough leptin or are you resistant to leptin? Same thing with insulin diabetes, the type 1, the type 1.5, and the type 2s, right?
Hmm.
So yeah, let's get into how does the GLP-1 agonist, and for the viewers that are unaware, the main generic ones that are approved for human consumption are semaglutide and
Semaglutide.
tirzepatide. Retatrutide is the third one that they're really trying to push through the clinical trials. I know that a lot of bodybuilders are already using that off-label kind of underground gray market kind of stuff. But
So
yeah,
did you say tirzepatide?
tirzepatide.
Yeah, so that is a dual agonist.
Uh-huh. Uh-huh. So what's the
So
difference? So in my understanding, Ozempic, semaglutide, is
yeah.
not nearly as powerful for weight loss and all these beneficial cardiometabolic outcomes compared to the dual agonist, the newer tirzepatide. Why is that? What is it a dual agonist of, and why is it so much better, more effective than simply semaglutide?
Yeah, let's that's a a really interesting point that you bring up. So let's once again go back. So I mentioned two incretins, but I only talked about one really, GLP-1. There is another one called GIP, gastric inhibitory polypeptide. And let's talk about why initially GLP-1 receptor agonists were only kind of thought of as the main pharmaceutical mechanism that we should explore. GIP also has activity on the alpha cells. So in the pancreas, we have beta cells and alpha cells. Alpha cells will increase glucagon. Glucagon will increase blood glucose. So if you are a diabetic, not optimal, right? Like, why would you have this? Why would you want more of this thing that causes the thing that you're trying to lower, right?
Mhm.
Um, so for a long while, it was thought of that GLP-1 is the incretin that we should target for pharmacological interventions of type 2 diabetes and obesity. However, as you mentioned, tirzepatide it as a dual agonist, so it works in on the GLP-1 receptor, but also it works on the GIP receptor, and it has been shown in clinical trials, and it's been shown for a while. And it's just kind of funny when we were first, working together. The drug tirzepatide was not even FDA approved, and now it's already better than Ozempic, and it's just kind of funny, like the time course of things, but. It is not necessarily 100% known the mechanism for that. There are a few schools of thought, and without getting too much into it, because I have, this data in peer review right now, so I don't want it to get out ahead of time. One I will speculate and being confidently said is that glucagon is catabolic. I think that a lot of people think of insulin and glucagon as this yin and yang without really understanding kind of what we've sort of been alluding to before is the body is resilient, but it's not this still thing that one thing happens and no reaction happens after that. There are consequences and then further actions after that. Glucagon is catabolic, and catabolic will, and what is it catabolizing? Well, sometimes it's breaking down fat cells, right, into usable energy that you can then use to make for energy later on, go through beta oxidation, for example, right? So what's really interesting is when they've done this in animal studies, when animals have high insulin, or in cell studies too. GIP is introduced. Well, it increases fat into the cell. But when there's low insulin, well, it causes fat to be broken down and used for energy. And now think about GIP activation in concert with GLP-1 activation. It, even though it causes that secretion in insulin, it's going into the cell. So then
Oh,
lower
okay.
insulin levels.
Yeah,
So now only we're dropping insulin glucose into the cells, but then after that, then maybe we're utilizing that energy because we're in a lower insulin state.
I gotcha. So this kind of just clicked in my head. Maybe it's right, maybe it's wrong. But perhaps the reason why milligram for milligram tirzepatide, the dual agonist, is more effective at weight loss in the long term compared to a single agonist like Ozempic or semaglutide is because perhaps by doing the GLP and GIP agonism, it is better mimicking a fasting state than the Ozempic is. Because in a truly physiologic fasting state, you're supposed to have low insulin and high glucagon in the first place. And with that fasting state comes fatty acid mobilization, beta oxidation, insulin is low, so there's no detriment to inhibit any sort of gluconeogenesis and use your stored energy as usable energy. Is that a correct statement here?
Yeah, I'm not actually sure I agree with that because these hormones are mostly postprandial, right? So that means after the meal. So you can measure these hormones fasting, and I have, and I have, like I said, data and peer review that does measure these hormones fasting, but I am not necessarily sure I fully get on board kind of with that because once again, these hormones are mostly postprandial,
Mhm,
and where we see the differences in the secretion is purely from a postprandial standpoint.
mhm,
And I do think that's important to highlight because as compared to a lot of other former diabetes drugs, which will risk hypoglycemia, these drugs have very low hyperglycemic events. And the reason for that, once again, is they're only activated in the constant and high blood glucose, which mimics more of a postprandial state.
Okay. So it kind of sounds like these incretins, if you're metabolically healthy, are almost a safety net for your body to prevent excessive adiposity or even elevated blood glucose after the meal, the postprandial state. Where does retatrutide come into the picture?
Yeah, so I think that it's painting the same picture as what I painted before with GIP and glucagon, where that is a triagonist. So then it also activates the glucagon receptors on the alpha cells as well. So I think that it's just doing the same thing on that, but now we just have a triagonist. I know that the trials are expected to be done by 2027. But again, early and we're FDA fully approved, but it does seem as if early studies do suggest potential efficacy of the triagonist over the dual agonist, and of course the dual agonist over the single agonist as well. So I think it's the same idea where it's really it's working on kind of both sides of the picture, right? And we kind of talked about metabolism as metabolic disease could be a dysregulation of the anabolism and the catabolism. Well, think about this: if these triagonists or dual agonists are helping you with your anabolism, insulin, but also helping you with your catabolism, the breakdown, the oxidation of that. So maybe they're kind of helping you from that regard and kind of resetting, if you will, resetting proper metabolism in that sense.
I see. When you say that retatrutide is a triple agonist, so the first two would be GLP-1, GIP. It's agonizing both. What's the third thing that it is agonizing?
So it's adenizing alpha cells to secrete glucagon.
Oh, okay. So it's increasing glucagon twice in two different ways, unlike tirzepatide, which is just the one.
Yeah, and I don't know if you have twice the glucagon secretion in that. I'm not familiar with that data. But maybe that goes to something that we can touch upon maybe potentially now is maybe it's not maybe about the amounts, but maybe the sensitivity to it, or which is the angle? Is it the concentration
Uh,
of the hormone or the sensitivity of the cell to the specific enzyme, to the specific?
uh-huh. Perhaps it's not a twofold increase in glucagon, but it's hitting it with two different vectors, if you will.
Yeah, I would agree with that. Yeah.
Okay, okay. Now, why is it that these new class of GLP-1 agonists are seemingly so much more effective at not just the weight loss, but reversing a lot of those negative cardiometabolic outcomes compared to the former drugs previously for these type of diseases, like metformin, the pioglitazones,
Yeah.
which are a class of the thiazolidinediones. TZDs to be abbreviated, sulfonylureas, DPP-4 inhibitors, SGLT2 inhibitors. What makes the GLP-1s so much more effective than these?
I think we have to kind of divide up those other drugs into kind of two classes. So you have insulin secretagogues, such as sulfonylureas, and those are associated with weight gain. TDZs also as a side effect, there has been shown in clinical trials to promote weight gain. So I
Mhm.
think that why GLP-1s are better than those class of drugs is easy because they cause you to lose weight. And a reduction in weight will, in most cases, improve insulin sensitivity, therefore improve in glycemic control. I think that that's a little bit easier to understand.
Uh-huh.
When it comes to metformin and SGL2 inhibitors, so again, I haven't done research specifically on that, so I would take it with a little bit of a grain of salt. Yeah, even though obviously, it's all metabolically related. How metformin works is even though it's ubiquitous, it is thought that it lowers AMP, it increases AMPK activation in the kidney, I'm sorry, in the liver, so it reduces hepatic glucose output. You mentioned earlier, like, gluconeogenesis, hepatic glucose output. What we know about individuals with type 2 diabetes and insulin resistance is they have higher hepatic glucose output. And what that does is that lowers the amount of hepatic glucose output, therefore lowering blood glucose. Metformin also has been shown to reduce weight as well in mechanisms that maybe are related to that, maybe not. So there's also, that's why it should be a little bit different. SGL2 is then in the kidney. So you have SGL2 inhibitor, SGL2 in the cell, in the kidneys, and those cause you to retain glucose. So SGL2 inhibitors basically cause you to excrete glucose instead of retaining it. And what we know is individuals with type 2 diabetes, not surprisingly, have dysregulation with that, where their body tells them to hold on to glucose when it probably shouldn't. Um, so my working theory on why GLP-1 receptors are potentially, I want to say better, why they are better than those drugs, specifically SGL2 and metformin, is what I described the mechanism for both those drugs, metformin and SGL2, as the consequence of diabetes. You already have diabetes, you already have insulin resistance. They were not causal. You do not develop diabetes because you have higher glucose output. You have higher glucose output hepatically because you have diabetes. But that's why I was so happy when you mentioned the incretin effect before, because we know a reduction in the incretin effect can drive adiposity and can drive an increase in glucose deterioration.
Yeah.
That can drive diabetes. And these drugs seem to be whether or not they're regaining the incretin effect again, which has been controversial in the literature, they still seem to be working within the main mechanism for what is causing diabetes. And
Okay.
that's kind of my working theory of the analogy that I like to use is if you or I are on a paddle boat, I have the lake a couple miles down from my house, and there's a hole in the boat, we have two options. We can get the water out or we can plug the hole.
Yeah.
Metformin, SGO2, I'm not saying anything bad about them. They get the glucose out, which is good. That's what you need because high blood glucose levels chronically is not good.
Hmm.
But they're not patching the hole. Well,
Yeah.
incretin mimetics, in my opinion, patch the hole. They stop the water from coming into the boat.
Yeah, yeah. So effectively, these SGLT2 inhibitors and the sulfonylureas and the metformins and the other drugs, the older school drugs, not the GLP-1s, they might make your blood work look prettier on paper. They might make you live longer because perhaps they are ameliorating the
Sure.
negative consequence, specifically hyperglycemia chronically throughout your whole life, but
Yeah.
they're not really fixing the root cause, which is you're fat as shit for most of these people. And that is fixing that is the perhaps most effective thing to fix everything else. You have high blood glucose because you have insulin resistance, because you're fat. The GLP-1s are so effective, perhaps because they really help with the weight reduction specifically, and that's the closest to the root cause. Is that what you're saying here?
Sort of. They have been shown to improve insulin sensitivity independent of weight loss, as well as improve reduce cardiovascular events independent of weight loss. So while I think the connection between weight gain and decrease in insulin sensitivity is definitely there, they're not always necessarily the same. And what's cool about these drugs is they seem to maybe potentially work on both sides of that, where the increase in adiposity, they decrease that, but they also do seem to have mechanisms that do actually increase individuals' insulin sensitivity sensitivity, which is the real thing, the real driver of hyperglycemia. So I wouldn't say it's a little bit of both, which is really exciting.
Multifactorial. It's
Exactly.
multifactorial.
Yeah, almost
Okay.
ubiquitously. Yeah.
Okay. Okay. Now, going back to the weight, why is it from a mechanistic standpoint that gaining muscle and losing fat generally tends to improve insulin sensitivity? What is the mechanism behind that?
Yeah. That is, let's take this from two parts. So, as I mentioned before, insulin resistance is inversely related with muscle mass, right? The more muscle mass you have, the less insulin resistant you are. And typically, it's a positive correlation for adiposity. More fat cells you have, more insulin resistance you are, or more insulin resistant you are. When it comes to the actual mechanism for what insulin resistance is, we spent a lot of time earlier kind of hemming and hawing and the nuances of terminology. We said insulin resistance a lot, and we just said that insulin resistance is being resistant to insulin, right? That's not super helpful. Part of the reason why is mechanistically, we're not 100% sure how that happens. We're confident as to why it happens because insulin is a polypeptide hormone and it's regulated by negative feedback. And just like and your body can tell yourself that don't take this in anymore. And when you think about why you would have high insulin, because you have high blood glucose and your body's saying no more glucose because we don't need that in the cell anymore. How exactly that works mechanistically is not 100% fully understood. And when it comes to the differences between muscle cells and fat cells, there are some key differences between the two. Obviously, both have endocrine and paracrine functions, but when it comes to skeletal muscle, its main role is simply just to create locomotion. And when we think about locomotion, that requires sometimes short-term energy, and that's glycolysis, short-term energy. So it makes sense that they would maybe prefer glucose as the main fuel. When it comes to fat cells, their job is to basically store it away for a later day. So their job is basically just to have this, and that way we can, break it down later in terms of if we go for long periods without eating, which throughout human history was very prevalent.
Mhm.
Um, so there seems to be a difference within maybe the preference of how the body uptakes that. So when it comes to muscle cells seemingly being more, maybe potentially more receptive to insulin. So therefore you have more, and therefore you're able to drop more glucose off, becoming less insulin resistant.
You have a
The
more of a
other thing,
buffer.
yeah, exactly. The other thing too that's I think really important to understand is we talked about the relationship of glucose to insulin, and postprandially that is correct. You need insulin to take glucose into the cells. There are certain contexts when that is no longer the case, and that context is specifically exercise.
Mhm.
Muscular contractions bring GLUT4 to this edge of the cells where it can take glucose in. It also can do that in fat cells too, interestingly enough. So when I think about people who gain muscle, really the only way to do that is through exercise, right? Like you're not going to gain muscle just kind of sitting there. You have to physically exert yourself. So I think from kind of both ends, it kind of works through both ways, where the muscle itself maybe mechanistically is a little bit more receptive to insulin, but the mechanism for how you got that muscle itself also independently allows glucose into the cells. So therefore, you're less reliant on insulin, which
Uh-huh.
is less
Uh-huh.
insulin resistance.
Yeah, it's the journey, not the destination.
Sure, yeah, I love that.
Okay, so to sum it up there and just make sure that we're on the same page, we know that in the long term, less body fat, more muscle mass, it's helpful. But the how, the mechanism, exactly precisely which signaling molecules involved, which hormones are involved, that's a little bit murky right now. However, in the short term, when we're talking about you going to the gym right now, you going for a walk right now, you doing sprints or swimming, that mechanism is pretty well established on exactly how the insulin sensitizing effect acutely occurs, and it has a lot to do with the GLUT4 glucose transporter. Is that
Yep,
correct? Okay.
yep,
So my understanding of that is you have many different glucose transporters in the body. When you're exercising, there's a greater metabolic demand in the cell, the muscle cell that you're using, which is a lot, and muscles are already pretty metabolically active. You exercise them, you contract them, they become even more metabolically active. Well, to do that, you need more glucose in the cell because you're going to use that for glycolysis and ATP production. It doesn't make sense to solely rely on insulin to drive that in when you're exercising because evolutionarily, I mean, when you're running from a saber-toothed tiger, you didn't necessarily just have a giant meal right before that.
Exactly.
You need the glucose in the cell right now, insulin or not. So what happens is your skeletal muscles will upregulate glucose transporters, such as GLUT4, that are independent of insulin to drive that glucose in. And by definition of insulin sensitivity that we've just defined previously in this podcast, well, you've just shuttled more glucose out of the serum into the cell with less insulin. By definition, you become more insulin sensitive. Is that an accurate statement there?
Yeah, man. Why don't you just teach my classes for me going forward? That's exactly
I
it.
I just wanted to make sure that
Yeah.
everybody is on the same page. Okay. So we know exercise is good. Can you give us some either prescription, not like an actual prescription, but
Yeah.
some guidelines, let's say, perhaps based on the ACSM, the American College of Sports Medicine, and maybe other like little tips and tricks for people to right now, right after watching this video, start to improve their metabolic health, specifically insulin sensitivity?
Yeah, I think, it really can boil down to how are you going to increase your muscle mass? I think that's really the most pragmatic and practical thing that an individual can do is an increase in muscle mass. And, that's where I think your world is going to shine because that is definitely your expertise in terms of how to do that. But in terms of kind of what my research has done, is we have kind of two general guidelines, not surprisingly, diet and fitness. For fitness, what we focus on is we focus on heavy resistance training in a progressive manner, focused on closed chain, full body exercises. So we have individuals, and again, these are individuals going through breast cancer, but they work and they work hard and they deadlift heavy, they bench press heavy, they squat heavy, they push heavy sleds, they do heavy farmer carries, they do all these things that drive a hypertrophic response. We tend to have them in a little bit of a higher volume, even though high volume isn't shown to be the main driver of hypertrophy anymore. Intensity, we keep it super intense as well, and we of course build them up so that way day one they're not deadlifting crazy amount of
So
weights.
intensity is a greater priority than volume when it really comes down to it.
For us, and the main reason for that is because keep in mind these women are going through breast cancer treatment, and volume will induce a lot of fatigue, and it will take a lot of time to get to volume. We know that early research said that volume was the driver of hypertrophy, but now we know that intensity can. We know this from research that's looked at three different rep range, 5, 10, 15, and when volume intensity was matched, they had the same hypertrophic response. So when individuals are going through chemotherapy, radiation, cancer treatment, their everyday life, we don't want them in the gym in a long period of time. We still want to induce that hypertrophic response. So we do that through a drive in higher intensity, more so than a higher focus on reps and sets. Now, once again, we make sure that they're scaled up, and we have CSCS individuals working with them. That way, they're doing that. And then the other focus that we do is we have them eat way more than what the RDA recommends. The 0.8 grams per kilogram is the RDA right now, and that was originally based off of nitrogen balance. But a lot of research has really shown that that probably should not be the RDA. That probably should actually be the floor. What we recommend is they eat way over that. We recommend anywhere from 1.2 to 1.6. On average, the women in our trial eat about 1 point
Protein,
protein grams per kilogram. Yes.
grams per kilogram. Oh, okay. I thought it was pounds, and I was like, this is a bodybuilding level
Oh
protein.
no, I apologize if I said pounds. I apologize.
Okay.
Uh, yeah, I don't think practically that, unless they're just like down in creatine that.
Yeah,
But
it's not gonna work in practicality. But I love that you mentioned the intensity aspect of that being a greater priority than volume if you have to choose, because that is right in line with a big educational concept that is part of our curriculum here at Train by Jay, which is also we focus on intensity over volume once their form is good. And
yeah, I mean, I was reading about that. I mean, I know that I'm being interviewed. Can you kind of speak to that? I'm kind of curious to your kind of thoughts on that.
absolutely. So with resistance training, there is something called the FIT VP principle. There's frequency, intensity, time, type, volume progressions. All of these variables do matter, But the two that we really focus on in practice is the volume and the intensity. So intensity is how hard are you going? How much percent of a one rep max are you using? Volume is simply how many reps, sets, and of course the weekly number, the frequency would also be accounted in there. But generally speaking, you cannot do both high intensity and high volume at all times. Because if you do, you're going to just overtrain yourself. And that is a real thing, by the way, that I didn't think it was back when I was in high school.
Yeah, overreaching.
But anyways, because you can't do both at the same time, it's kind of like economics. The whole point of economics is there's a finite number of resources. It wouldn't be a problem if it was infinite, but it is finite. Which one should we allocate? The guns and butters, right? How much guns, how much butter, right? How much to rent, how much to your car? Same thing with volume and intensity. You can maximize one at the expense of the other. The question is, which one is more conducive for most people for not just bodybuilding muscle growth purposes, but also in this case of being anti-diabetic, anti-metabolic disease? Is it the high volume, low intensity? Or on that spectrum, on the other end, is it low volume, high intensity? 9 times out of 10, I see the best results for the high intensity, low volume group. And the reason for that is partially adherence. People can get more done, shorter sessions in the gym, so they don't have to
Yep.
spend 3 hours in the gym. That's one part. But also, if you go into the gym with the mindset of, I'm going to do 6 sets of bench press today, subconsciously, you're going to hold back from
Hmm.
going balls to the walls for the first couple sets because you know that you have to do a bunch more sets after. However, on the other hand, if you go into the gym and at the extremes, Dorian Yates, Mike Mentzer kind of style, and was like, this is the one chance. This is my one set of bench press for this week. This is it. You're going to empty the tank. And at the biochemical level, one thing that happens is, first of all, volume is a greater driver of systemic fatigue.
Yeah.
At elite levels of training, your fatigue, if you're not getting injured, is going to be a big limiting factor for you to keep progressing. If you
And that
have
makes sense, right? Muscle contraction and increase in
Yeah, yeah, we're
protons. Yeah,
talking
exactly. Yep.
systemically, your nervous
Yep.
system, your endocrine system. If you're having to do tons of volume, even if volume and intensity were equal for anabolic response of muscle growth in the tissue, well, you're accumulating way more systemic fatigue with the high volume, low intensity, as opposed to the latter. And that's going to make you have to go on unnecessary deloads way more
Hmm.
frequently. So you're not going to be progressing. But at
You
the
actually ironically lower the volume anyways.
yeah, yeah, and it's going to force you. It's if you're doing too much, your body's going to force you to reduce one or the other or both. Now, at the biochemical level, I know Jared's going to appreciate this because he actually co-authored the paper that we published a few years ago on the mechanisms of hypertrophy. I'll put the link down in the video here. Look at me, Jared. Look at me. I'm a fucking influencer, bro. I'm a YouTuber now. But anyways, Brad Schoenfield was a guy that was able to kind of helped me to understand this when I read his research. In your body, there is thousands of different chemical reactions, metabolism, that occur in response to the stress state of resistance exercise, of which there is something called the mitogen activated protein kinase family, the MAPK kinase.
Yep.
This is effectively the master junction of mechanotransduction. If you break that word down, mechanical, your resistance training, how is that transduced into biochemical signals to ultimately yield biochemical adaptations, such as muscle growth, fat loss? MAPK has 3 arms as it relates to exercise. P38, J and K, and just a regular ERK, extracellular rated kinase MAPK. Okay.
Yeah.
Of these, when you do low intensity exercise, you only stimulate one of the 3 arms, and that arm that is
Right.
stimulated only causes fatty acid oxidation. If you go beyond a certain intensity threshold, which appears to be at failure or very, very close to failure, you not only activate one of the 3 MAPK kinase family arms, but you activate all 3. Not only are you mobilizing fatty acids, burning fat, but you're tapping into changing gene transcription. Your body is being forced to adapt because it's reached the threshold necessary in theory, to have to adapt and build more muscle. So, in layman's terms, if you just go to the gym and go through the motions, you're just going through the motions. You're just burning calories. You have to go balls to the walls time and again, here and there within reason to drive adaptations, especially if you want to keep progressing year after year. Does that make sense?
Yeah, so in terms of those three arms, can you also talk about in relationship, because this is something that, I think you would be really well versed to speak on. Can you kind of speak on how mTOR is kind of related with those three terms? Because people hear mTOR in my world, and a lot of people are actually very afraid of mTOR because it's cellular growth. You mentioned earlier cancer is unregulated cellular growth.
Mhm.
So a lot of people in the cancer field hear mTOR and it's like the boogeyman for them. I was wondering if you can kind of can continue with the three arms of cellular within that in relationship to mTOR.
Absolutely. So, really, to answer this question, we got to kind of answer the question of how skeletal muscles grow in the first
I
place,
didn't set it up right, but yeah, yeah,
right? Yeah. So, I appreciate that, Jared. So, to your point there, mTOR is the master regulator of growth. You turn on mTOR, you are turning on protein synthesis,
yeah,
and also you are turning off protein breakdown. Now,
TBJ.
mTOR is just one of the signal molecules that are involved. There's a whole bunch of other ones like FOXO, tissue sclerotic complex, TSC, AKT, P13 kinase. But the point is, you turn on mTOR, you are now in a net protein anabolic environment, or at the very least, a net not catabolic environment. You're going to turn off muscle protein breakdown. So, as everybody who's watching or listening to this podcast probably understands, muscles are not grown in the gym. You actually break down muscles, and that's a catabolic effect.
Yeah,
Now, in response to that, with the proper recovery and the proper nutrition, that's where the anabolic adaptations happen. So effectively, Lane Norton, I believe, is one of the PhD researchers that when he was trying to get his PhD, when he was doing his master's thesis, kind of elucidated into this, is there is almost a priming effect of mTOR sensitizing, if you will, very similar to how insulin, this podcast topic, is sensitized in response to exercise acutely, not in the long term
yeah.
only, but also right after you exercise, your mTOR gets sensitized to want to be turned on, essentially. So, really, what's happening here is you go to the gym, you break down your muscles, you break down your glycogen into glucose and use that for ATP. You're turning on catabolic signals such as AMPK kinase.
Mhm.
But by extension, shortly after, because of that net catabolic event that happened, now your body really wants to grow. You just got to give it the right food. So now you give it the protein, the carbohydrates, it spikes your insulin a little bit. You're pretty insulin sensitive, so it's probably not going to be a huge spike, but you have your bowl of cereal. Every bodybuilder that I know does this. They eat their big bowl of cereal, they down their protein shake that has a complex array of amino acids, all the nine essential ones.
Sure.
And now there are amino acid sensors that are closely right next to in proxy with the mTOR molecule.
Yeah, Gator. Yeah.
So yeah, Gator, Castor, Cestrin, right? So things
Mhm.
like arginine, things like L-leucine, especially L-leucine.
BCAA, sure. Yeah.
Yeah, BC, it's one of the three branching amino acids, perhaps the most important one for muscle building
I would argue. Yeah.
purposes. Yeah, I think the effective dose is it 3.2 grams in one sitting? Is that
300. So yeah. Yeah. 300
okay?
milligrams. Yep. Yep.
So if you do a one scoop of a quality whey protein, you're going to probably hit that, if not more. But basically, to get your protein shake in, you've just done this super catabolic event of broken down your muscles in the gym because you trained hard and you're not a loser and you actually train. You get this protein shake down, which has all the molecules that you need to turn on mTOR, such as L-leucine, such as insulin, such as IGF-1. That kickstarts the cascade of protein synthesis, specifically muscle protein synthesis. And why is that important? Because your muscles are the stores of protein in your body in the same way that your fat is the store of triglycerides in the body, right? So in relation to that, there's a lot of crosstalk with mTOR and MAPK, as well as the WNT-FCD pathways and NF-kappa B for inflammation. But really what's going on is there's two things that happen if you get the right recovery and you stimulate mTOR. On one end, you're stimulating protein synthesis, which is mostly what your muscle is made out of, other than water. the actual contractile units. We're talking like
Right, right.
myosin heavy chain, the actin, the troponin, tropomyosin, all of that stuff related to the stroking of the oars, contraction of the muscle, that's all protein. You're building that.
Mhm.
But there's also something called the myonuclear domain. And in essence, the theory there is your muscles are multinucleated. So unlike most cells in the body, your muscle cells can have multiple, and they actually will have
They do, yeah.
multiple nuclei for the given cell. So not only are you increasing protein synthesis with the mTOR pathway, but you're also getting more myonuclei into there because the myonuclear domain theory suggests that there is a pretty stable myonuclear domain, and that would be one myonuclei and the amount of volume of muscle cell mass that it encompasses and kind of controls or governs with its DNA within that myonuclei. So you're increasing muscle protein mass, myonuclear hypertrophy, right? You're not going to get too much hyperplasia with grown adults unless you blast growth hormone, apparently. But you'll get a lot of myofibrillar hypertrophy, but you'll also get the myonuclei to also come in from the satellite cells, which are just right next to the muscle cells themselves. So it's this whole orchestration of more area with the proportionate amount of myonuclei to come in there at the same time. Okay.
Yeah, and I think that makes sense kind of when you think about that. We don't store amino acids, right? We have a small store of amino acids, about 100 grams, but we can store fats and we can store fats and we can store carbohydrates, but we can't store amino acids, right? So I think kind of what you're describing with giving your body the amino acids after that event of it being broken down, well, they're being sent there exactly for that. I think that kind of conceptually makes sense to me, at least.
Yeah, yeah. And one last thing that I will add here is a lot of bodybuilders will supplement with amino acid beverages, BCAAs, EAAs while they're working out, because the idea here is, especially the leucine in there, it will prevent muscle protein breakdown. Now,
Well,
the
isn't that the idea with insulin too? Because insulin does stop the degradation of muscle breakdown. So isn't that kind of the idea? You mentioned the bowl of cereal. I mean, we know that about 20 grams of carbohydrates will induce that, but isn't that kind of the same idea there?
Exactly. So to your point there, it's not so much that you're trying to prevent the breakdown of the muscle that you're training. Clearly, the whole point there, if you're training biceps, you're trying to grow your biceps, you have to break down your biceps. But the idea of having insulin as a pre-workout, maybe with carbohydrates, fully glycogenating your stores with even amino acids in there, is that it will perhaps protect the other muscles that you're not training that otherwise, if you're
Mm,
really doing bodybuilding, 2 hour grueling workouts,
one
you're
thing,
probably
yeah.
going to tap into your protein stores, your other muscles, and start to break those down as well, right? And we do know that generally, as exercise duration increases, there's a greater cortisol response. And
Of
unlike
course.
growth hormone and epinephrine, which are more acute, they're not substrate specific. They're not going to just break down fats.
Yeah.
Cortisol is going to break down muscle, bone, nerve, anything else as well.
Mhm.
Okay, so you're trying to blunt that effect effectively. Okay.
Yeah, that makes sense. Yeah.
Yeah. Anyways, I'm not a big fan of amino acids with a couple exceptions, maybe if you're vegan, maybe if you're super deep into bodybuilding prep, mainly because it does block mTOR. And bodybuilders are always eating around the clock, always eating high carb, high protein. You're never really giving mTOR a chance to stop. And the real problem with that is premature aging because you're always redlining protein synthesis, but there's a cap to that.
There's no
But at the
tap.
same time, you're preventing protein breakdown, including the very necessary autophagy, which is the catabolic but very necessary process to get rid of damaged cells and organelle components. Okay. So I would say generally for most people watching this, do not waste your money on amino acid supplements.
How do
But
you feel about, not to get us too derailed, but how do you feel about maybe not people who are bodybuilding, but one of the things that we talk about in some of my studies is for individuals who we are recommending at 1.2 to 1.6 grams per kilogram, that can be sometimes hard through natural food if they're not having like, boneless skin, like skinless, boneless chicken, right? Like even lean beef is still at like 85% where it's still 15% fat. So how do you feel about for those individuals, at least from a pragmatic standpoint of like those protein shakes where you can get like a bolus of 40 grams of protein with essentially like I forget what most of them are. but like what, like 5 or 6 grams of carbs on top of that? Like that's a very high protein to energy ratio. So what's your kind of take on that?
I would say I used to think that it was just about the macros. And then I started to learn about if basically what is now pretty much known as the food matrix theory. So, have you heard of the food matrix
No,
theory?
I haven't.
Okay. It's essentially the idea that there's a synergistic effect of food. So, for
So
example,
it's not the nutrients, it's the food. Yeah.
it's not just the nutrients in the food, it's everything else in that
Yeah.
food that helps with the nutrients. For example, let's say that there's a fruit with a lot of vitamin C, but you don't just take the vitamin C like a
Right.
supplement. There's other components in that food that would help or hinder the absorption of that vitamin C. So you're literally interacting with that food and changing your biochemistry every single time that you eat something.
Right,
Probably
because vitamin C helps
designed.
with iron absorption.
Yeah.
Sure. Yeah.
Yeah. So to that point, if you're super new to this, I think just tracking your calories, just tracking your protein, it's probably a good step in the right direction. And of course, just like we said in the beginning of this video, if you have to pick two variables, those two would probably make the most sense for any
Yep.
kind of outcome that you're looking for with health and fitness and bodybuilding. But if you really want to get down to this and truly optimize your performance and maximize your genetic potential of your body composition, which is effectively what every bodybuilder is attempting to do with or without the drugs, you need to understand the actual science behind food as a whole and how that is affecting your gut, affecting your inflammation, affecting your hormone status, right? Because that's going to dictate where the food goes. It doesn't matter how clean you're eating if your body's just storing everything as fat, which is pretty much the case of prediabetes, insulin resistance, type 2 diabetes, right? Um, Okay, so last question here. It's a little bit of a curveball, but I just got to ask because I feel like you'd be the great guy to ask for this. A lot of bodybuilders think they're super healthy because they don't eat sugar, but they're pounding sugar substitutes. Sucralose, Ace K, aspartame. It's in the pre-workouts, the Ghost energy drinks, the protein shakes. Most of these are sweetened with that. They're probably doing upwards of 3, 4, 5 servings a day for years. What's the implication of artificial sweeteners on perhaps insulin sensitivity?
Great question. Definitely a big curveball. I am not super familiar with it specific to insulin resistance, insulin sensitivity. Um, what I will say is actually just I read this the other day. Funny enough, it does seem as if these substitutes are better for metabolic consequences than compared to actual sugar. So it does seem as if that is the case, and if a lot of these diseases are driven by adiposity, having less calories would drive less adiposity. So maybe potentially that's simply just the mechanism, is maybe it's just a reduction in calories. Where I'm a little bit hesitant to that, though, as you mentioned bodybuilders. So I'm not necessarily sure that maybe that's the best answer for them because you went on this really elegant soliloquy about how it's about the food itself and all these organisms and how the and within the organism how that connects. So maybe it's not necessarily just about the food it's about the food in relationship to the exercise being performed as well, because we know that less than a third of Americans meet the standard of the recommended physical activity guidelines. So when this research was done, it was specifically done in an average population. So maybe for the average population, that's the case, but maybe in bodybuilding or other contexts of athletic performance, maybe that is necessarily not the case. So I don't necessarily really know that, but I
Yeah.
think it's an interesting
So
point.
So between a full sugar Coke and a Diet Coke, if someone's already obese and just gonna have horrible cardiometabolic outcomes of their obesity, probably the Diet Coke makes a lot more sense. But I was actually
Probably.
listening, yeah, but I was actually listening to a video the other day that was outlining potentially the problems with this. There's got to be more research. Nothing's really set in stone yet. But there's two things that artificial sweeteners chronically in excess definitely affect, probably for the worse. We just don't have the proof yet necessarily, at least to really have a objective stance on this. And those two things are one, negative effects on the gut microbiome, which now is definitely becoming more of a topic of interest in longevity health research. Your gut health affects your whole body health. That is the first frontier of you and
Yeah.
the environment, essentially. If
Yeah.
that's fucked, you're screwed, right? Secondly, is when you have something sweet in your mouth, whether it's sugar or fake sugar, there's some sort of response to that, such as the dopaminergic type of response.
Sure.
And even now, we've discovered that there's the incretin effect. There's a difference in eating 100 grams of sugar down your mouth and injecting it. Perhaps there's also a negative, considerable response to having something that tastes sweet in your mouth and your body's starting to ramp up these molecules, these hormones, getting ready to absorb that sugar, and then it never comes, right? And now you're starting to essentially manipulate your reward circuit of and even your relationship to food and how you feel in your mood, right? And that will change behavior, change appetite, and so on. So definitely this is a topic that we're going to need more research on, right, Jared?
Yeah, I largely agree with what you said. I do find it interesting though, because I think the counter to that would be that in these longitudinal research studies, they would maybe kind of balk at that and say that maybe that is true, but maybe the overall health outcomes are still attenuated because it doesn't have that increase in weight gain as opposed to the natural sugar, right? So I think a potential way of looking at that is if you would have to somehow like have a weight controlled group, like one group that gained weight and one group that didn't,
Mhm.
because maybe it would be in the people that gained the weight regardless of the sugar substitute that would then cause that. But yeah, I mean it's definitely an interesting thing. One thing, not to prolong this, but you brought up an interesting point of like the dopaminergic effect of the brain, right, with the sugar. It is really interesting to kind of tie this and make this full circle that we only talked about the main effects of what those GLP-1 receptor agonist drugs do. But one of the things that when going presenting data and talking with actual clinicians, is they say anecdotally that individuals eat less, and that mechanism hasn't been fully understood. But once again, the reason why this kind of made sense is you're right. You do start breaking down carbohydrates in the mouth immediately. Like you put a cracker in your mouth, it will turn sweet eventually, right? And that potentially is getting, you're going to start an increase, maybe potentially in GLP-1 and GIP, maybe potentially like something like that. So maybe in the sense of that there are thought to be some like neurophysiological effects of these drugs. Maybe there's sort of kind of a world of connection between kind of all of what you just kind of said potentially. Just kind of, piqued my interest there.
Yeah. So if there's any researchers that are watching here that want to have a further discussion, should they contact you, Jared?
Yeah, I'm always open for collaboration. Right now, mostly what I do is student-led projects. So if anyone else wants to kind of jump on in or take some of my students under their wings and give them better guidance than I can, of course, please.
Okay, awesome. Well, Jared, I really appreciate your time here today. I think this was fantastic. This is my second ever podcast, and I
Oh, I'm
don't think I
honored.
clip anything else. So this went very, very well. I appreciate your time, and I'm going to stop recording right about now.